Good evening. I'm Spot On Weather meteorologist Matthew Euler. And for tonight, I thought I would take a little bit of a break from the summer weather video training series and go into describe the actual weather at a specific location on the Earth's surface. And with this week's video, I thought that it would be really cool to show the Arctic and generally what's going on in the Arctic, the type of weather that we see in the Arctic, the temperatures, the precipitation, and the very unique relationship of the Earth to the sun in this particular area of the Earth. Now, as you most likely have heard, the Arctic is warming twice as quickly right now as the middle latitudes. So we're seeing the effects of global warming for sure in the Arctic areas where we're having much lower Arctic sea ice extent as well as rapid melting of northern glaciers. But there's a lot of cool, interesting things when we talk about the Arctic, so let's get right into tonight's video. I hope you enjoy it. First of all, with the Arctic, let's look at the overview of it. During the winter time in the Arctic, much of this area receives little or no direct heat from the sun. In other words, the sun is low on the horizon, even in the summertime. And it sets completely during the wintertime, where you're going to have nothing but darkness during the wintertime across the Arctic area. Now, there's cold winter temperatures, which are common in the Arctic, which many of us associate with the Arctic, right? This results from a lack of the sun's energy. Even during the summertime, and I'll get into the latitudes and the amount of daylight hours distribution here in the video, but I want to really make a key point here in that even in the summertime, when areas north of the Arctic Circle, north of 66.5 degrees north latitude, even though they are the land of the midnight sun, where the sun is out 24 hours a day, the sun is just above the horizon. It's not very high in the sky, and as a result, the sun's energy, those electromagnetic waves of energy from the sun, have to pass through a greater amount of atmosphere. In addition, you have a lot of ice and snow in the Arctic, which has high reflectivity for the incoming sunlight. So even though you have 24 hours of daylight, let's say, in the Arctic area in the summertime, it still has colder temperatures because of the low elevation of the sun above the horizon, a lot more scattering of that light before it reaches the ground, as well as the fact we have ice and snow, which is great reflectors of heat energy from the sun. Now, the land-sea ice distribution and the mountain barriers, they contribute to tremendous variation in the climate at different points at similar latitudes. So in the Arctic Ocean, or the Arctic area in general, the Arctic region, we have mountain barriers. It's not just smooth terrain, and we'll get into that here in a moment. Additional facts about the Arctic. In the Northern Hemisphere, the water features include the Arctic, the North Atlantic, and North Pacific Oceans. So when we talk about water features in the far northern latitudes in the Northern Hemisphere, we have to talk about those three bodies of water: the Arctic Ocean, North Atlantic Ocean, and the North Pacific Ocean. These bodies of water act as temperature moderators since they do not have large temperature variations. The major exception is when large areas are ice covered in the wintertime. Whenever you have areas that are largely covered by ice, they tend to act more like a land mass when that water is completely covered by ice. Now, land features include the northern continents of Eurasia, the North American area, Greenland, and the Canadian archipelago. Land areas tend to show the direct results of extremes in seasonal heating and cooling in the Arctic by larger seasonal temperature variations, and I'll go ahead and show you that here momentarily. When we look at the Arctic geography, I have two main maps that kind of show how the Arctic is classified. If you look at the graphic on the left, there's a blue dashed line there. That's generally the latitude portion of the delineation of the Arctic, and there is a red solid line on that graphic on the left. That red solid line indicates The 50-degree Fahrenheit isotherm in July. Lines of equal temperature is an isotherm, as I mentioned in previous training videos. So some on the left define the Arctic by using that 50-degree Fahrenheit isotherm, that red line. Anything north of that red line is colder than 50 degrees Fahrenheit on average throughout the entire year. Others, meanwhile, if you look at the right-hand graphic, pretty much stick to the latitude lines, the 66.5 degrees north latitude. That red dashed line is representing that 66.5 degrees north latitude. And you generally have anything north of that is considered the Arctic region. Okay? So, two different classifications, but in general, you get the idea from this slide where the Arctic region is specifically. All right, so now the Arctic mountain ranges of Siberia and North America, they play a big role. They're factors which contribute to the climate and air mass characteristics of the region. Again, we're not dealing with completely flat and smooth land. We do have mountain ranges in the Arctic region. The mountain barriers are going to restrict the movement of air from the west to the east. And during periods of weak circulation, the air is going to be blocked by these mountain ranges and remains more or less stagnant, not really moving a whole lot. Air is going to then acquire the temperature and moisture characteristics of the underlying surface, which we'd expect it to be very cold in the Arctic with the ice and snowpack. These areas serve as air mass source regions, and they are particularly effective as source regions during the winter, especially when the surface is covered with that snow and ice. So we have very cold air overlying these snow and ice fields in the Arctic region. Please refer back to previous training I've given on this the air mass training. I do specifically talk about source regions as areas where air masses form. Now, just wanted to again get home the point on this particular slide that the Arctic is not flat. It has elevation. I did do a couple red circles there on this slide to denote some of the more mountainous terrain of the Arctic. Okay, so across the Bering Sea into northern Russia, there are some higher elevations, as well as in northern Alaska, there's some higher elevations on the North American continent. But again, this is a topographical map kind of showing you those changes in elevation at the higher latitudes that are considered in the Arctic region. The Greenland ice cap, it's really cool. I was lucky one time to be on a plane, and literally we flew right over the Greenland ice cap. It was really cool. Took a plane ride from Iceland over the Greenland ice caps into eastern Canada, and it was really amazing to see those ice caps below our plane. But the Greenland ice cap is getting a lot of recognition in the news lately, especially when it comes to global warming and how rapidly that ice cap has been melting. This ice cap is essentially a mountain range, so it has higher elevations associated with it that goes up more than 10,000 feet above mean sea level. It restricts the movement of weather systems, ice cap, often causing lower pressure centers to generally move northward along the west coast of Greenland. So if you lived in Greenland, the west coast there of Greenland is going to have a lot of the storms and low pressure areas. And you see some of the largest rates of falling pressure in the world occur there also, outside of those hurricanes and tornadoes. High winds are very common along the west coast of Greenland due to the deep low pressure centers. You get extremely tight pressure gradients, large pressure changes over short distances. And at times, winter temperatures in the Arctic are unusually high, believe it or not. You wouldn't think so. And we've seen this recently, winter temperatures being unusually high at far northern latitudes, but much colder down here in the United States. This situation, when this occurs, when you get warmer temperatures in the Arctic in the winter, is brought on by deep low pressure centers that are moving into the Arctic, coupled with compression of air, as it often blows down off the edges of these ice caps. You know, at very high elevation, as air flows downhill, it's going to warm and compress. All right, so now that we got the overview of the Arctic, you're kind of introduced to I've introduced you to the topographical features that we just don't have smooth terrain. We have higher elevation areas, as well as the geography, the two types of classifications for the Arctic region, the 50-degree Fahrenheit isotherm, as well as those lines of latitude, we're now going to talk about the Arctic air masses. Now, one thing you should know is the moisture content of these air masses in the Arctic, it originates over land, and it's low at all altitudes in the winter. The temperatures are always cold in the Arctic area for the most part year-round. Distinction between air masses during the summer almost disappears because of the uniform surface conditions over the Arctic and subpolar regions. And you get these frozen surface thaws under the influence of lengthened and continuous daylight. So you do get some thawing of the ice in the summertime, especially when you got 24 hours of daylight. Snow does melt from the glaciers and pack ice. The ice is going to melt in lake areas, and the Arctic is there as well. And water areas of that polar basin increase markedly. So the polar area in the summer becomes mild, humid, and semi-maritime in nature, with temperatures usually between the freezing point at 32 degrees Fahrenheit and 50 degrees Fahrenheit. Now, during the winter months, air masses are formed over areas that are completely covered by ice and snow, as I mentioned previously. Air masses are characterized by very cold surface air and a large temperature inversion in the lowest few thousand feet. When I say temperature inversion, that's referring to temperatures actually warming with height above the ground. Cold Arctic air is very dry. Okay, and that's the one misnomer that many people, they just automatically assume it's snowing all the time in the Arctic region, when that completely is not the case, because the colder the air, the less moisture that air can hold, and therefore, with cold Arctic air being very dry, it's just not going to produce a lot of high annual amounts of snowfall. So many people get that a little bit mixed up in their mind. The air masses originating over the oceans now in the Arctic region, they do not have a surface temperature inversion in the wintertime. The surface air temperature is generally warmer with a corresponding increase in moisture content of the air. You get extremely cold air to move over an open water source in the Arctic region. It's going to pick up moisture from that water source and actually cause the moisture content to increase. Now, during the summer months, the large expanse of open water, so as this ice melts, you get the thawing of the frozen surfaces, those lakes. It's going to result, the large expanse of open water and warmer temperatures in the Arctic is going to result in increased moisture as well. And consequently, the amount of cloudiness and precipitation that occurs during the summer months, you're going to get a lot more of that cloudiness. And in fact, I will give you a personal story. I traveled one time from Hawaii all the way up into the Bering Sea, there just west of Alaska, and every day, I was up there between July and September, every day I was up there, we had nothing but thick fog and low stratus clouds, and the fog was so thick, at times it was less than 1 mile visibility, and it was just day after day after day. The temperature and dew point were very close together. You had this warmer air trying to move in over the colder water surface there, the open water surface of the Bering Sea, and it just socked my location in day after day with fog and stratus clouds, sometimes some drizzle. But that usually is the case up in the northern latitudes, especially over the ocean or the open water areas there. Now, Arctic fronts. The weather associated with fronts, it has much the same cloud structure as a polar front, like we'd have here in the United States in the wintertime, when you get one of those strong cold polar fronts move through, except that the middle and high cloud types are generally much lower in the Arctic, and the precip is pretty much going to be primarily in the form of snow in the Arctic as compared to the mid-latitudes. There is periods of maximum surface wind that usually occur during and just after these Arctic frontal passages. And you get strong wind, which often creates hazards such as blowing snow and turbulence, which makes operational flying difficult in this region. There's been many explorers in the past that have gone up to the Arctic region, and they've discovered this problem, especially if trying to fly through the Arctic region. You generally have a lot of blowing snow restricting your visibility, stronger winds, which kind of creates more bumpiness or turbulence in the atmosphere. The best flying weather over the Arctic, over land, usually occurs in the middle summertime as well as the middle wintertime. The worst is usually when you get low ceilings and those visibility restrictions occurs during transitional periods between the two seasons, between summer and winter. Winter is generally characterized by frequent storms and well-defined frontal passages, but again, the Arctic region does not get a lot. They're not going to get a storm that's going to produce 12 to 20 inches of snow or anything crazy like that. And that is mainly due, again, to that dryness of the air. Clouds and precipitation are generally at a minimum after these frontal passages, especially in the Arctic. Now, in summer, there's going to be fewer storm passages, and the fronts are generally weaker. However, you do get increased moisture in the air, which results in more widespread clouds and precipitation. Now, over the sea areas, which I just described with my own personal experience, the summer weather is very foggy with lower wind speeds as compared to wintertime. And I will tell you again, as a first-hand witness, that is definitely the case up there, especially in the Bering Sea. During transitional periods of spring and fall, operational flying conditions are usually the worst, with well-defined active frontal systems, and icing may actually extend to higher levels at that point. So that's something to keep in mind if you are a pilot and you ever have to fly up in this particular region. As far as Arctic temperatures, we have the image in our mind of generally what the Arctic, what it feels like, right? All we're thinking about is, brr, it's cold. Temperatures are going to be very cold most of the year. Now, the interior areas of the continental particular land areas of Siberia, northern Canada, and Alaska, they actually may have pleasantly warm summers with many hours of sunshine each day, believe it or not. Now, there are large temperature differences in the temperatures between the interior of these land masses in the Arctic area versus the coastal areas. We'd expect much more drastic changes in the temperatures throughout the course of the year in the interior areas, away from the modifying influence of water, for example. So in the interior during the summertime, temperatures can actually climb to the middle 60s to lower 70s and frequently rise even as high as into the upper 70s or lower 80s, occasionally into the 90s. And we've seen this happen in Alaska. For example, Fort Yukon in Alaska has recorded an extreme high temperature of 100. Can you believe it? Triple-digit heat in Alaska, while Verkhoyansk in north-central Siberia has recorded 94 degrees Fahrenheit. So these northern continental areas, these continental areas in the Arctic region can get pretty warm in the summer. And with global warming, we've seen increased frequency of well above normal temperatures across the Arctic region. During the wintertime, the interior areas of Siberia, northern Canada, and Alaska, they act as a source region for the cold Arctic air that frequently moves southward into the middle latitudes. The coldest temperatures on record over the northern hemisphere have actually occurred in Siberia, believe it or not. So Siberia can have some of the coldest temperatures on record. Now, in the northern areas of the interior regions, temperatures are usually well below zero during the wintertime, with long periods of darkness and near darkness. And temperatures normally fall to negative 20 to negative 30 degrees Fahrenheit. Now, these are the temperatures. This isn't even the wind chill. Now, in some isolated areas, the normal daily low temperature may drop to negative 40 degrees Fahrenheit. In north-central Siberia, the normal minimum daily temperature in the winter, usually the normal low temperature, you believe this in north-central Siberia, is between negative 45 and negative 55 degrees Fahrenheit. So very, very cold. You definitely want to be bundled up if you ever go up to that particular area in the wintertime. Now, the Arctic coastal regions, they're interesting in that they include the Canadian archipelago, and they're characterized by these cool, short summers. During the summertime, the Arctic coastal regions, the temperatures normally climb into the 40s or lower 50s. Occasionally, temperatures can reach the 60s, but there is almost no growing season along the coasts, with the temperature falling below freezing during all months of the year. So you really don't get a growing season. Like in the United States, you look forward to the spring and summer where you can plant vegetables. You're just not going to get it up in these Arctic regions along the coasts. Again, the temperature falling below freezing during all months of the year. Now, at Point Barrow, Alaska, for example, the minimum or low temperature is going to rise above freezing, that 32 degrees Fahrenheit mark, on no more than about 42 days per year. That just kind of gives you a little perspective. Now, over the Arctic Ocean, temperatures are very similar to those experienced along the coast. However, the summer temperatures over the Arctic Ocean are usually lower. Winter temperatures along the Arctic coast are very low, but not nearly as low as certain interior areas. And on rare occasions, the temperature will climb above freezing during the winter months, above that 32 degree Fahrenheit mark. Coldest readings for the coastal areas range between -60 and -70 degrees Fahrenheit. The flow of heat from the water under the ice has a moderating effect upon the air temperature along the coast. So if you get any kind of breaks in the ice, that water, it's not going to be super warm by any means, but relatively speaking, compared to the nearby colder land, it is going to be relatively warmer compared to that land. And you can get some of the moderating effect of that heat coming up from that water surface, impacting the overlying air mass. Now, I wanted to show you climographs, these examples of two locations. We're looking at Barrow, Alaska at 71 degrees north on the left, and then we got Nuuk, Greenland on the right. Now, Nuuk is about 64 degrees north latitude. It's just technically south of the Arctic Circle a little bit. I just wanted to show you the general tendency of the temperatures as well as the precipitation. I do have the temperature precip there on the left for Barrow, for example, up at 71 degrees north latitude. And you notice January, February, and March on the graphic there on the left are generally pretty steady as far as the average temperatures, right around between -10 and -20 degrees Fahrenheit. That's the average. And then you'll notice that curve, that red line kind of curves up, that almost form like a hill shape. So the warmest month is generally about July in Barrow, Alaska, sitting just above 40 degrees Fahrenheit on average. And then as you come back to wintertime, of course, these temperatures again get much colder. By December, you're looking at -10 degrees Fahrenheit. So overall, the range of temperature from 40 degrees, just about above 40 degrees Fahrenheit, as cold, down as cold as -12 to -15 degrees Fahrenheit. Now look at the green bars there for Barrow, Alaska. That shows you the monthly average precipitation. And again, in wintertime, the air is so cold and dry that you'll notice that there really isn't a lot of precipitation in January, February, March, even April and May, as well as November and December. It's very scarce in the Arctic area, especially over those land areas, because the air is so cold and dry. August looks like it's the wettest average month there in Barrow, Alaska, and that's just around 1 inch of rain, and that's it. That's it. If you went somewhere down south along the Gulf Coast of the United States, it'd be a much different story, right, with the amount of annual precipitation you get. Now, Nuuk, Greenland there on the right, just this graphic shows you the average high temps and the average low temps. This is in degrees Celsius. But again, I just want you to pay attention to the curve. Things are fairly constant in January, February, and March with the average temperatures. And then you see that spike up to July timeframe, the warmest month in Nuuk, Greenland. You're almost at 10 degrees Celsius, which is about 50 degrees Fahrenheit. And then you notice that decline again as we head into October, November, December, where it gets much colder again. And then the blue line there on the right shows you the average low temperatures. So it averages in February and March in Nuuk, Greenland, -50 degrees Fahrenheit is an average nighttime low. So yeah, it's very cold there as you would expect. As far as Arctic cloudiness, at a minimum, the clouds are at a minimum during the winter and spring months, and they're at a maximum during the summer and fall. The average number of cloudy days for the 2 6-month periods show a general decrease in clouds across the entire Arctic area during the winter months. The greatest seasonal variation is found in the interior, with the least seasonal variation along the coasts. To just show you a little bit about clouds in the Arctic. Now, during the warm summer afternoons, in the interior region, scattered cumulus clouds form and occasionally develop into thunderstorms. You wouldn't necessarily associate the Arctic region with thunderstorms, But they are possible. They're normally widely scattered. They very seldom form continuous lines. We're not going to see the kind of severe squall lines that we would get across the southeastern United States up in the Arctic. Along the Arctic coast and over the Arctic Ocean, thunderstorms occur infrequently, very rare. Although tornadoes have been observed near the Arctic Circle, they are extremely rare as well. And in these areas, summers are quite cloudy with stratus clouds predominating. And again, that's my example over the waters, unfrozen waters of the northern latitudes, the Arctic area. Typically get these low stratus clouds and a lot of fog, especially in the summer months. Seasonal changes in cloudiness do take place quite rapidly in the Arctic, with winters characterized by extensive cloudiness in the coastal regions. There's a lot of cyclones and storm systems that tend to form, and that results in a lot more cloudiness with these migratory low-pressure systems, and the clouds generally disperse inland as the systems lose moisture. As far as the Arctic winds go, the wind speeds are generally light if you go into the continental Arctic interior areas throughout the year. The strongest winds in the Arctic are going to occur during the summer and fall in the interior when you do see them. During wintertime, the interior continental regions are areas of strong anticyclones or high pressure activity that produce only light surface winds. High pressures are generally associated with light winds and weaker pressure gradients. Strong winds occur more frequently along the Arctic coast as compared to continental interiors. And that has again to do with that storm track and much tighter pressure gradient, much stronger wind along the coastal areas. The frequency with which high winds occur in coastal areas is going to be greatest in fall and the wintertime, when you got a much more energized, stronger jet stream overhead and a lot more atmospheric dynamics, creating a lot more mixing in the atmosphere, a lot stronger winds. And these winds are frequently going to cause blowing snow. And one thing I should mention too about the Arctic with the snowpack is it's more fine and powdery and dry. So it tends to get picked up more easily by the wind, say in a location further south. In the U.S., for example, when you get temperatures near 32, 33 degrees, you get the heavy wet snow. That moisture content of the snow, the wind's not really going to be able to blow it as readily as a place like the Arctic. All right, and so you get very strong wind speeds. They have been observed at many Arctic coastal stations. Strong winds are usually infrequent over ice pack. And winds blow continuously because there are no natural barriers to retard the wind flow. And the combination of wind speed and the low temperatures, so faster wind speeds, higher wind speeds and colder temperatures are going to produce very cold wind chill temperatures. They can be extreme and severely limit outdoor human activity. As far as Arctic precipitation goes, again, I'm really hammering the point home tonight in the video, but precipitation amounts are small. They're very minimal. They vary from 5 to 15 inches annually in the continental interior and only 3 to 7 inches along the Arctic coastal area over the ice pack. So very minimal precipitation throughout the course of the year. The climate over the Arctic Ocean and adjoining coastal areas is as dry as some of the desert regions of the mid-latitudes. So that just goes to tell you how scarce precipitation can be in some areas. Most of the annual precipitation is going to fall as snow on the Arctic Ocean and adjacent coastal areas and ice caps. And on the other hand, most of the annual precipitation falls as rain over the interior. So you can get colder rain in the Arctic regions in the interior portions. It is possible. As far as restrictions of visibility in the Arctic, there's two factors that we want to take into account. First of all, that cold, dry air is exceptionally transparent with extreme ranges of visibility possible. But on the other hand, there is a lack of contrast between objects. When you get that wind to blow the light snow off the ground, you can get a case where you lose that contrast between objects, especially when you're looking on the horizon, when you have a new layer of snow. This can actually make it very hard to distinguish objects. So limitations of visibility in the Arctic region are going to include that blowing snow as well as fog and then even local smoke. Blowing snow is going to constitute a more serious hazard to, let's say, flying operations in the Arctic because, again, as I already mentioned and explained, that snow is fine and dry and powdery. It's easily picked up by those winds, so it's going to easily restrict the visibility and be a hazard to those flight ops. Wind in excess of 8 knots, it can raise the snow several feet off the ground, with the blowing snow obscuring surface objects such as runway markers. So it can be a challenge to take off and land in such conditions in the Arctic. Fog is perhaps the most important element restricting the flying in the region. There's 2 types of fog, advection fog and radiation fog. The difference really here is advection fog occurs when warm, moist air blows over a cooler surface. So you do have some form of wind. That warm, moist air is being advected into the area, those cooler areas of the Arctic via wind. And then you have radiational cooling, where you have such extreme cooling at night, the lower levels of the surface, long-wave Earth radiation is sent upward away from the surface, and that can also result in a fog. Now, fog is most frequently found along those coastal areas and usually lies in a belt parallel to the shore. In winter, the seas are generally warmer than the land areas, and you get relatively warm, moist air that is being advected over the cooler land areas, causing the fog, that advection fog. This fog may be persistent, so it may last for days on end, and so that makes flying even more difficult in the Arctic area. In summer, you get warm, moist air being advected in over melting sea ice, producing fog, as well as over those open, unfrozen water bodies. One unique thing in the Arctic is you get this thing called ice fog, which is composed of these minute ice crystals rather than water droplets that we'd see here in the United States. And it's most likely to occur when the temperature is about negative 45 degrees Celsius. If I converted that negative 45 Celsius, it would be negative 50 degrees Fahrenheit, or colder. But can occur when temperatures are as warm as negative 30 degrees Celsius or negative 20 degrees Fahrenheit. So ice fog is definitely a problem, and instead we've got these ice crystals in the air instead of the water droplets. Now, one unique aspect of the Arctic area is something called sea smoke or steam fog. This occurs during the winter months. The inability of cold air to hold moisture. I mentioned this earlier in the video, that cold air does not have the capacity to hold very much moisture. All right. That inability of that cold air to hold moisture results in what's known as sea smoke in the Arctic areas. And it occurs when you have open bodies of warmer water and extremely cold air that's moving over those warmer water areas. And that is going to result in quick saturation of the air mass, causing what appears to be like a sea smoke, similar to steam fog forming over hot water. In the case of sea smoke, the temperatures of both the air and the water are quite cold or low, but the air is still going to be colder above that water surface, causing steam to rise up from the open water to form a fog layer. And this is going to occur frequently over these what's known as leads in the Arctic region. These leads are navigable passages in the ice pack. Additional effects of restrictions of visibility in the Arctic include Arctic haze, where you have a condition of reduced horizontal as well as slant visibility, but you generally get good visibility looking straight up from the ground. It's encountered by aircraft in flight over Arctic regions, it's been reported, and there's cooler effects which suggest this phenomenon to be caused by very small ice particles near the ground, sometimes referred to as Arctic mist or frost smoke. When the sun shines on these ice particles, they are called diamond dust. It's like they sparkle. Right, so now we're moving into the last topic on tonight's video. Let's talk about some weird peculiarities about the Arctic. First of all, you get these strong temperature inversions present over the Arctic during much of the winter. And this is going to cause several interesting phenomena, such as what's known as mirages. You can get some really strange, what appears to be the refraction of light on the horizon really produces some strange-looking objects that really aren't there. Additionally, you get sound under these temperature inversions, which carries greater distances. Again, keep in mind that an inversion occurs when you have much colder air near the surface and the temperature is warm with height above the surface. So you get a warmer layer of air above a colder layer of air. So sound is going to basically travel greater distances beneath these inversions. On some days when the inversion is very strong, human voices can actually be heard over extremely long distances, believe it or not. Now, as I mentioned before about the mirages, these light rays in the Arctic are bent as they pass through the inversion at low angles. This may cause the appearance above the horizon of objects that are normally below the horizon as well. Again, this effect is known as looming. Now, this is a form of a mirage, looming, where it's like what you normally would see above the horizon is flipped and it actually occurs below the horizon. Mirages that distort the apparent shape of the sun, the moon, or other objects near the horizon are common under temperature inversion conditions, where you get really strange shapes. When you look at the sun, it doesn't look circular, it might look kind of elongated. Some of that sun, the moon as well. Now, one of the most interesting phenomena in the Arctic is going to be the aurora borealis, or those northern lights. These lights are brightest at the Arctic locations, and I'm going to show you an example of what that looks like here in a minute. Intensity of light is going to vary from a faint glow on certain nights in the Arctic to a glow which illuminates the surface of the Earth with light almost equal to that of light from a full moon. So it's really impressive how that light can be magnified over the Arctic areas. Now, reactions from auroral glow have been observed to reach heights of approximately 300,000 feet in the Arctic, way, way high up. Now, the amount of light reflected from snow-covered ground is much greater than the actual amount reflected from the darker surfaces of the middle latitudes. Keep in mind that snow has a high albedo, high reflectivity, so the amount of light is much greater as compared to a darker surface. As a result, you get useful illumination from equal sources being greater in the Arctic than at lower latitudes. Now, when the sun is shining, you get sufficient light, which is often reflected from the snow surface, to nearly obliterate shadows, causing a lack of contrast. This could be a case where you have inability to distinguish outlines of terrain or objects at short distances. So that is quite unique. We don't normally see that in the mid-latitudes. Now, the situation is even worse when the unbroken snow cover is combined with a uniformly overcast sky, and the light from the sky is equal to that reflected from the snow cover. In this situation, you can have all sense of your depth and orientation being lost. And this is known as a whiteout. It's represented by the appearance of a uniformly white glow. Pilots flying in the Arctic have reported the light from a half moon over a snow-covered field being sufficient enough for landing aircraft at night. I mean, can you believe that? I just can't imagine that. And it is possible to read a newspaper on occasions by the illumination of a full moon in the Arctic. All right, so you could be sitting in a dark room, through your window the moon is shining, and you might actually be able to read a newspaper by just the illumination of a full moon. All right, as promised, I wanted to show you kind of what northern lights look like. In this particular image, it's a green coloring here. These are some of the coolest phenomena that the atmosphere produces. Generally, they're caused by collisions of electronically charged particles. It excites the atoms of gases in the upper atmosphere. When you have an active sun with a lot of solar activity, that active sun tends to send these countless numbers of charged electronic particles in the upper atmosphere. It's most frequently concentrated over the magnetic poles, the North and South Pole. In the Northern Hemisphere, it's known as Aurora Borealis. In the Southern Hemisphere, over the South Pole, it's known as Aurora Australis. So just wanted to show you, this is another cool, interesting aspect of the Arctic region. All right, that wraps up the video tonight on the Arctic. I wanted to take you to a unique location on the Earth and kind of go over different aspects of the Arctic, just in case you were curious. This is where to find us, Spot on Weather on Facebook. There's our Facebook Spot on Weather page. Hit like to that page and follow us. We also are on Instagram and Twitter as well. My main platforms I post the updated forecast are going to be on Facebook and Twitter. and also on the Spot On Weather Weebly site. There's our website address. This is a great site. Subscribe to us for the most up-to-date, most accurate forecasts. And we certainly appreciate everybody, again, subscribing to our video. We really love to share the weather with you at home. If I have a moment here, let's see. I am going to go, I think I have it up here. Do I have it up here? Yep, I do. All right, this is the Spot On Weather website again. Just wanted to show you a quick tutorial on it. In general, we have a blog that we do regularly. This is my latest blog that was done yesterday. But you can see all the archive blogs here on the right-hand side of the web page. We also have a 7-day weather forecast, which we do regularly, updates on daily, kind of showing you the next 7-day forecast for Southeast Virginia. Additionally, we got plenty under the More tab here on the Spot On Weather website, including this amazing photo gallery here. We're always updating pictures on it. Whether we can go back in time. Here's some Amatus clouds from July in the Norfolk, Virginia area. And this is just one example of some of the images we throw in here. Here's a nice little towering cumulus cloud. But we got a lot more photos in there of all the seasons in Virginia. Additionally, we have synoptic discussions that are posted from the National Weather Service, the Hurricane Outlook, daily weather maps, which we archive. And you can follow, you can see the archive tabs there and the month and the years there under archives. But we do this on a daily basis, so you can kind of get a look. If you're interested in knowing what the weather was like on a certain day across the United States, you can go to the daily weather maps tab. There's also the daily U.S. temps tab. We save these on a daily basis, showing you the high and low temperatures for specific locations in the United States, including Alaska and Hawaii. Additionally, we have daily U.S. precipitation, so if you're interested in knowing whether a location was wet or dry on a particular day, this is courtesy of the COCOROS website. We have that as well as daily satellite images, just kind of showing what the weather looked like across the Mid-Atlantic region on specific days. And then we also have, let me continue to move on here, we also have U.S. temperature anomalies, which I save on a monthly basis from the NOAA climate data. So you can kind of see the red areas indicating above normal temperatures for specific months, blue indicating below normal temperatures for specific months, and so on. And I do the same thing I have a tab down here for U.S. precipitation anomalies for the various months. You can kind of check that out. As well as global temperature and precipitation anomalies. Did I not take it? There it goes. In general, this is from WMO, the World Meteorological Organization, generally showing you the above and below normal temperatures and precipitation for specific months across the globe, so you can get a good look globally at what's going on with the weather. As well as our Weather Archive tab on the Spot On Weather Weebly site, where we save monthly weather summaries, National Weather Service summaries, for Southeast Virginia. I specifically focus on the Virginia Beach, Hampton Roads cities area. Additionally, we have great weather links here. You're really going to love it if you really want a good source of links. We've had some really good feedback from various groups already, positive feedback about them appreciating us having all these links available for some research type things. But we just added this week the bottom one here, which is the NOAA Weekly Archive Weather Maps link, which you can go back and look at the weather across the United States, the weather maps anytime. You can go back in time and see what the weather was like on specific days, which is really cool if you click on this link here. Additionally, we have the World Meteorological Organization Climate Explorer, and just tons of more things here on the website. You're really going to like it. Check it out. That's all I got tonight. Spot On Weather. Thank you again so much for subscribing. We have a passion for the weather and certainly appreciate it. Follow us on Facebook and Twitter. And that is all I've got tonight. I wish everybody a pleasant evening. Take care, everybody, and God bless.